Hello, I welcome you all. The problem reads the ball A has a mass of 3 kg and is moving with a velocity of 8 meters per second when it makes a direct collision with ball B, which has a mass of 2 kg and is moving with a velocity of 4 meters per second. If E is equal to 0.7, determine the velocity of each ball just after the collision. Neglect the size of the balls. This problem is coming from other engineering mechanics and dynamics of 14th edition by R.C. Hibbeler. So momentum here is conserved. When we consider a system of particles. Okay, so been told that so let's pick the reference. So this is our reference, this is x, this is y, positive like so. Okay, so what we need here, so we want to use the conservation of momentum. So we are saying MA VA1 plus MB VB1 just equal to MA VA2 plus MB VB2. Okay, so what is MA there? So this one is 3 kg. So MA is equal to 3 kg and MB is equal to 2 kg. Alright, so this becomes a 3 by 8 plus a 2 by minus 4. Okay, minus because we've chosen our reference in that direction. Therefore, anything in the opposite direction, consider it negative. So this is just 3 VA2 plus 2 VAB. So this just becomes 24 minus 8. 24 minus 8 is a 16. 16, 3 like so plus like so. This is equation 1, right? That's 3 by 8 minus 8. So found the first set of equation. Alright, so now let's apply the this coefficient of restitution. Okay, so E here is just equal to VB2 minus VA2. Okay, so we're assuming, and then we have VA1 minus V1. This is in a case where we're assuming VB2 is greater than VA2. So E here is equal to 0.7. VA1 is equal to 8 and VB1 is equal to minus 4. See, it's in the opposite direction to assume direction. Okay, and therefore we'll have 0.7 equal to VB2 minus VA2 divided by VA1, which is 8, minus VB1, which is a 4. Therefore, this just becomes 8.4 equal to VB2 minus VA1, VA2. This is our second equation. Solving this set of equations. So we do have, I make VB2 here subject to a formula, just becomes 8.4 plus VA2, and we do have 16 there, which is equal to just VA2 plus 2 VB2. So solving the two, so we can always plug in this value there. So if we did so, then we'll have a 16 is equal to 3 VA2 plus 2 8.4 plus VA2, and therefore our VA2 is just going to be equal to 16 minus 2 by 8.4, 16 minus 2 by 8.4, okay, then divided by 5. So this gives us a minus 0.16 meters per second. Therefore, this just simply means this is equal to 0.16 meters per second, and it's going in the opposite direction of our assumed direction, right? And then we do have VB2. We're going to use this equation where this one. So we do have minus there plus 8.4. So this gives us 8.24 meters per second. And therefore, this is just going to be equal to 8.24 meters per second, and it's going in this direction like so. Right, here we go. We do have these values, and these are the velocities of each ball just after collision. So I hope this video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and sharing my channel. Bye bye, and I'll see you in my next screencast.